mathematics. Now we would like to take a look at how to graph a parabola in standard form. The standard form, if we want to learn how to get the focus, is 4p y minus k equals x minus h squared. Now we set the number that is here equal to 4p in order to find p, or the distance the focus is from the vertex, how many spaces above or below or left or right depending on the graph, how far the focus is, and the directrix will be the same equal amount. And we'll use another video to explain how to find our focus and directrix. So this looks a little familiar. It looks a little bit like a circle's equation, only they're both on the same side and they're both squared. So in a parabola, only the x is squared or the y is squared, only one of them at a time. So this sort of parabola would be pointing upwards. If we were to put a negative sign here, it would be pointing downward. So the h and the k are going to be much like a circle. We use the same letter. Those are going to be our vertex points. And our vertex is going to be the one next to the x goes into the x spot, h. The one next to the y goes in the y spot of our point, and we call it k. Now if you notice, the formula has a negative sign in it, but the vertex doesn't. And what that means, one way to look at it, is that we're going to take the opposite sign of whatever is inside of the equation. Or if we start with a vertex and make an equation, we're going to take the opposite sign. And we'll take a look at that and look at some examples. So oftentimes we'll see this as y equals x squared or y equals negative x squared. And we don't want to forget there is a parabola that has y squared. It would be x minus h equals y minus k squared. So when we have a graph like this, it's going to be rotated to the right and facing to the right. And when we have it negative on any side, it's going to rotate it to the other direction, to the left. So we would often call this x equals y squared to make it more simple, and x equals negative y squared. So we're going to focus mainly on the vertical ones. They are the same exact process, however, so you can graph any type of parabola this way. So let's get started at how it all works. When we take an equation of a parabola, let's say on its vertex, it's going to look like this. So there's no number like we looked at previously that represents h and k, so the vertex here is going to be 0, 0. So what happens if I put a number next to the x? Let's use an actual number, not h. Well, now my vertex, again, in my x position, I'm going to put the number next to the x, which in this case is a negative 4, but remember, we're going to change the sign, positive 4. And so next to y, there's no number. We would represent that one in the y value spot of the point as a 0. And so when both of them have numbers, sometimes you won't see a parentheses if there's no number in front, let's say, like a 4. Again, now we're going to look in the x spot, and that's our x value. So we will change the sign, 3, and we'll look in the y spot and change the sign and get negative 2. So when you graph a parabola, the vertex is the spot, sort of like where the graph originates, and then it goes to the right or to the left, let's say, in this example, and both sides are symmetrical, meaning they're exact copies of each other or reflections. So we'll look at that in another video, but we could draw a line through the middle here and create a line of symmetry. So after we found that vertex point, the question is, what is the next step? So let's start an entire problem and graph it. So let's take an equation, y minus 1 equals x minus 2 squared. So again, if there's a number in front or a negative, they'll often put the parentheses, but other times they might not, so it might look like this. But it's going to work the same way. So our vertex, we'll look in the x spot to get the x value and change the sign. That negative means change the sign. So we'll get positive 2, and negative 1 will change to positive 1. So what I tend to do is make a chart to keep my students organized, and I'll put that vertex kind of in the middle. So let's start taking a look at what we have so far. What we have so far is the vertex, and what that means is our starting point. So let's get started here. We're going to graph to the right 2, up 1, and that is our vertex. Now because the number in front of the sign in front of y is positive, we know this parabola will be facing upward. If there's no negative in front of the x or y, it's going to be facing upward. Otherwise it would be pointing down. So what I tell my students to do is you typically could take 1 point to the left and 1 point to the right of the vertex. So 1 point to the left would be 1 for the x value, and 1 point to the right would be 3. So what I really am doing here is subtracting 1 from the vertex and adding 1 to the x value of the vertex. And we're going to plug those points into the equation to find our y value and where to graph. Now we don't have to just do 1 to the right or 1 to the left. We could do 2 to the right and 2 to the left. We don't have to do 1 space to the left and 1 to the right. We could do 2 spaces over. It just depends on the graph though. Sometimes it'll go off of your paper. So just as a general way to sketch at first, we typically go 1 to the left and 1 to the right. So we're going to take this x is negative 1 and plug it into our equation. We're going to write the equation we started with and put 1 in for the x value. Now I'm going to take the point of 0 where x equals 0 and I'm going to plug it into the original equation. So I have it written down here, and I've substituted the x for 0. Everything else is the same. Now I'm going to solve 0 minus 1 is negative 1. Negative 1 times negative 1, or negative 1 squared, is 1. And I have negative 1/4 y plus 2. Now the quickest way to get rid of this fraction is to multiply both sides by the reciprocal. 4 over 1. We can also multiply it by the negative at the same time, and that's going to give us the ability to cancel the negative on the left side and cancel out the 4's. So we now have y plus 2 equals negative 4. I'm going to subtract 2, and I get y equals negative 6. So let's write that again, and now plug in x equals 2. So if x equals 2, we have the same setup, y plus 2, negative 2. I'm sorry, positive 2 minus 1 squared. So all I did here was plug in x equals 2. And in doing that, I'm going to get the same number, 1. 1 squared is 1. And to get rid of, again, any fraction, we multiply both sides by the reciprocal. So I'm going to multiply by 4 over 1, or negative 4 over 1, to also get rid of the negative sign on the left side, because we're trying to get y alone. So now we have y plus 2 equals negative 4. And when we subtract 2, we get the same answer, negative 6. So because the parabola is symmetric, if we went 1 to the right and 1 to the left of the vertex, the two answers should be the same. Or if we went 2 to the right and 2 to the left. So let's take a look at what we have now. 1, 2, 3, 4, 5, 6. So plugging in the 2, negative 6 would be here, and plugging in 0, negative 6 would be here. And we sketch it. So what we noticed in my class when we looked at our software was when the number in front here was a big number larger than 1, what it does is it stretched out the parabola wider. So when it was less than 1, like a fraction or a decimal, it made it more narrow, skinnier. And so if we look at the one we just did, it was a fraction. And so it did make the parabola a tiny bit skinnier or thinner than it normally would. So that's the basics of graphing a parabola. We could do the same thing with the parabola where y is squared. So drawing a parabola that is going to be pointing to the right or to the left is going to have the squared on the y variable. So we're going to graph it the same way with one very minor change. So the vertex we get the same way. The one next to the x value we put in the x spot, but we change the sign. The one next to the y spot we change the sign also. And so our vertex is going to be 2, -1. And that would be here. So understanding that the parabola is going to face this way, we're only going to make one small change. When we put in our vertex of 2, -1, we want to go one above and below the vertex because now the parabola is facing a different way. So one above will be 0 for y and one below will be -2. So we're going to plug in the y value in order to solve to get x. And this is the only change in graphing a parabola facing in the different direction. So let's do that. X minus 2 equals 0 plus 1 squared. X minus 2 equals 1. And when we add 2, we're going to get x equals 3. And we could do the same thing. X minus 2 equals -2 plus 1. Okay, we're going to get -1 squared, which is 1. And when we add 2 to both sides, we get x equals 3. So now we can graph the actual points, 3, 0, which will be here, and 3, -2, which will be here. And our parabola will be facing this way. So those are the basics of graphing a parabola. Sorry about my computer fan, you could probably hear it. We find the vertex, we plug in one or more points to the right and one or more points to the left. The more points, the more accurate. So for example, if I plugged in -3, I would get 4, 6. I would get 6. So I can actually go over 4, 5, 6, 6, -3, and it would be about here. So the more points we graph, the more accurate our parabola will appear. And of course, graphing it on a computer software will be even more accurate, or on graphing paper. So good luck to you.